Hello and welcome to an attempt to show you more fun programming in Common Lisp. For as long as I've been programming, a fun hobby has been to write programs that help me cheat at word games. Today I'm going to show you a word Descrambler program I wrote in Common Lisp. Let's do a brief demo. You can see we very quickly descrambled 4 words. It doesn't take too much code in Common Lisp to do this. OCount is a utility that counts lines of code. It only takes 23 lines of Lisp code to do. I could do it in less code, but that would require bad practice, and I'll explain that when we get to it. Let's look at the code in the Emacs text editor. I'll maximize this. That is 100% of the code that is needed to do this. Sure, it looks complex, but we'll explain it all. I'm going to start a program to help me explain it within Emacs called Slime. Slime is the superior Lisp interaction mode for Emacs. The Common Lisp I'm using is SBCL. You can see here. That's a Steelbank Common Lisp. For trivia purposes, a steel bank is a play on the names Carnegie Mellon. Lisp originated at Carnegie Mellon University. Carnegie's fortune came from steel, and Mellon was a banker. Hence, Steel Bank Common Lisp. So the trick of descrambling words is to find words in the dictionary that have the same letters as the scrambled word. So I need 2 inputs: a list of scrambled words from the user, and a list of words from the dictionary, and a method to reliably compare the two. So the lowest level function is to build a comparison key, and that's this function right here. Let's evaluate it. Slime, menu, evaluation, eval defun. So that evaluates a function definition. And you see it successfully incorporated get compare key into its environment. Let's show you what it produces. Get compare key, compare key, a scrambled word. It turns it into a sorted list of letters. How does it do it? A good way to understand a basic Lisp function is to start at the innermost parentheses and work your way out. So the first thing that happens is we string downcase the input word. I imagine most of you have already guessed what this does. It turns the uppercase letters into lowercase. Basically, we need to have the letters in a common case to be able to compare them. Now we move out to the next set of parentheses. What does this do? Well, coerce turns the result of the string down case into a list type. So it turned FIFICO here into a list of the same letters. The trouble is, this is still difficult to compare for two different words because of the order of the letters. We need a common ordering scheme so that we can easily compare to see whether two words have all of the same letters. I chose, for a common ordering scheme, an ascending list, and that's what happens when we go to our next set of parentheses. We sort the list that we have produced. The meaning of sort is obvious. It puts it in an order. We supply a comparison function to the sort command. The comparison function is string less than. The pound sign means reference. The apostrophe means function. So we are supplying the sort command, or function really, a reference to the function string less than. Here's a simple numeric example of what we're doing. So we're sorting this list using as a sort function a reference to the function less than, and that's numeric less than. You see it puts it in the right order. An ascending order in this case. If we change the referenced function to greater than, what happens? Well, then you get a descending ordered list. So, back to this, the defun defines this as a function called getCompareKey. And this function, because I evaluated it earlier, if I evaluate it again, it'll probably say it's redefined. Yep. Warning, redefined getCompareKey. So it's available in the Common Lisp session. And we can evaluate it by putting the cursor anywhere in the function and re-evaluate it the way I just did by going to the slide menu, evaluation, eval defun. There it goes again. Now let's look at how to get user input. We're using command line parameters to get our user input, and it happens down here at the bottom of the file. The variable name for the list of command line arguments in SBCL is *POSIX-ARGV*. Unfortunately, this is different in different Lisp implementations. In C Lisp, it would be *args* like that. You'll notice that this code is not in a defun, so it runs immediately when we run the script. When we run the script, it runs the def constant up at the start, then it evaluates all the defuns to give this Lisp session all of the functions that we defined, and then it runs this code. So let's go through how this code evaluates. The first thing we do is get the length of the arguments we received. The first argument is always the name of the script itself, and then the following arguments are counted 2, 3, 4, 5, 6, etc. So if the length of the arguments is greater than 1, then we run the Describable function. Else we run the usage function, which is right here. And all it does is it tells you why the code isn't doing anything, because you didn't give it any arguments to be descrambled. The if function in Lisp only allows calling one function for a then condition and one function for an else condition. So if we only supplied the command line name and no arguments other than that, we would call usage. Otherwise, if we provided some actual words to be descrambled, we would call the Describable function. What this does, when we call the Describable function, it calls it with the rest of the arguments. So the first argument is omitted when we say rest. So it takes, instead of argument 1, it's not included, it takes the arguments after the first argument, so the second, third, fourth argument, however many you have. So now let's look at the Describable function. And it has a parameter inwards. Inwards is the rest of the arguments supplied to the script. The first thing I do is use let to assign a list of search keys for each scrambled word I specified on the command line. Mapcar runs a function on each element in the inwards list. You specify the function to use the same way you specified the function to use for comparison in sorting, with a reference to the function. Remember, the pound symbol means reference. The apostrophe symbol means function. And the function that we're using is getCompareKey, which we just talked about in probably too much detail. So every inward gets run through getCompareKey and has its result assigned to this list of search keys. That's actually pretty simple, isn't it? With OpenFile creates a file stream. We called the file stream dictionary so we'd know what it was. And the file name for the dictionary stream is dictionary file. Let me actually make slime disappear so we can see more of the code on screen at once. We defined dictionary file as a constant up here. A def constant can't be changed, so dictionary file always remains the same unless you change the source code to point at a different file. And I'm using the Linux dictionary user share dict words. So we come back down here to where we were. There's dictionary file. There's the stream that represents the dictionary file. The next thing is a do loop. The first thing we do is set the initial value of dict word. And we set it to the result of this function, readline dictionary nil. What does that mean? We read a line from the file stream dictionary And if we get no value, we return nil. Why do we have readline twice? Here's why. This sets the initial value of dict word. This sets the subsequent values. So for each step in the loop, we run this code, not this code. It doesn't really seem to make sense to a person until you understand that in a different do loop, we might, for example, set the variable dict word or whatever we call it to 0, and then maybe set it to the current value of dict word plus 1 in this second statement. So the initial value of dict word comes from read dictionary. We go through the loop, we come back, then we execute this code for every run through the loop after that, or every step through the loop. Step would be the normal word you'd use for that. What's this thing? We need to know when to stop looping. The null function tells us when readline assigned the nil value, which means it hit the end of the file. So when we hit the end of the file, oh sorry, I over highlighted. When we reach the end of the file, dict word is set to nil, which means null returns true, which means we stop doing the do loop. A bunch of things that you'd have to do manually in other languages do not appear here. We don't have to close the file, because after we leave with open file, the file will be closed automatically. And we can just simply read in the loop itself instead of in a separate construct inside of a loop. So it's actually quite simpler. Doesn't necessarily look simpler, and it can be a chore the first time you learn to do loops to get the number of parentheses correct. For each iteration through the loop, that is each step through the loop, we call the checkword function with the search keys that we set up here in the let statement and the dictionary word that we're reading from the dictionary on this step of the loop. And that's it. That's all we have to do to run through the whole dictionary. What does the checkword function do? It's right up here. Here we have the checkword function, and the search keys, don't forget, are all of the keys for the words we supplied at the command line. And dict word is the single word from the dictionary. So the first thing we do is we use let to assign a variable, dict word key, and we assign it to the result of get compare key dict word. So now the search keys are a sorted list of the letters in a word, and the dictionary word key is a sorted list of the letters in the dictionary word. Then we run do list, which tells us for each search key in the list of search keys, we check to see if it is equal to the dict word key. So we go through each search key for all of the words we input and compare them to the key we developed from the dictionary word. And if we have a match, if the list of sorted letters is equal, then we handle the matched word and supply the dictionary word that had the match. Here is the definition for handle matched word. And all it does in this code is it calls right line with the matched word, which we called with dictionary word down here. So here it is dictionary word. It is supplied as with the parameter name matched word, and then we write the dictionary word to the screen. This begs the question, why wouldn't we just have right line matched word down here where we call handle matched word? The reason is to avoid side effects. In functional programming, we want a function to do one thing, and then that function is more reusable. What if this was a GUI application or a web application, and instead of printing the matched word on the screen, we wanted to add it to a drop-down list? Well, then handle matched word would be redefined to add the word to a drop-down list. What if we wanted to write the word to a database? Handle matched word would be replaced with a function that writes the word to a database. Then all we have to do is replace the handle matched word function, and we do not have to modify the check word function at all. So there's a simple Lisp program explained in detail. I hope that was useful and interesting. Let me know if you want me to do more of these. Although the language is called Common Lisp, it isn't that common anymore. But if you learn how to program in Lisp, I find it makes you a better programmer in every other language you use. See you next time.